Okay, today we will be working with factoring a bit more. So if you will please make sure you put your objective number in the upper left corner, 1.2. Still on Unit 1, but now Day 2. And we're just going to title this More Factoring. Okay, next thing we're going to write down is factor completely. And number 1 is xy cubed minus 2xy squared plus 5xy minus 10x. Now, if you remember from yesterday's notes, I talked about there being 4 terms, and what I think of when I see 4 terms, first thing my brain processes is factor by grouping. Factor by grouping. And if you remember yesterday in the notes, I said the most common first one that you probably learned was a 2-2. And then you should have learned a 3-1 and a 1-3, and if you haven't, we're doing it. We did it yesterday, and we'll do it again today. Okay. The more you do, the better you will become. Like I can see here that that is not a perfect square trinomial, nor is that a perfect square trinomial. 10 is not a perfect square, 2 is not, x is not, nor is that x there. Same problem here, they're not perfect squares. So I'm not going to try the 3-1 or the 1-3. I'm going to work with the 2-2. And I'm going to factor the first GCF of the first 2 and the GCF of the last 2 terms. All right, so what is the GCF for your first set? You're looking right there only. They have an x in common, they have a y in common, and no numbers, just variables, and that is possible. So it is x y squared, x times what is x? No x's, no x, but I need a y. Xy squared times y is xy cubed. Take away 2, and no variables because the xy squared is already taken care of. That's it, y minus 2. Plus, what's my GCF here? I can see there is a 5. Looks like there is an x. 5x times what is 5xy? That is a y minus 2. 5x times y is 5xy. 5x times negative 2 is negative 10x. And then from notes before on yesterday's lesson, I talked about this, and you've done this in your previous math classes. Think of this, recognize that there are 2 terms. There's your first term, there's your second term. They're big and chunky, but they're still terms. First term, second term. What common factor do the 2 terms have? They have this y plus 2. Y plus 2 is your common factor. So take out the GCF. Neither one of these are a squared, so you're not taking out y minus 2 squared, just y minus 2. What does that leave you with? xy squared plus 5. X. Now we have a problem here. Right in here, there is a GCF. Now I'm hoping some of you caught it. That means there was a GCF to begin with. Does anybody see that now? X and X and X and X. That means from the get-go, you could have taken out a GCF. Now, rather than chucking all of this and starting over, I'm going to give you a tool where you can fix it from here. You simply look and ask yourself, what is a GCF? There's a GCF of x. So take the x out. I just like to put it in the front because I don't like it sitting in between 2 parentheses. So I'd put the GCF of the x, the y minus 2 stays y minus 2, and factoring out an x gives me y squared plus 5. No more GCF in any of these. This is your final answer. Now again, if you don't like this, you can start from the get-go, taking out an x from everything and then doing your factor by grouping with the x sitting on the outside. Okay, number 2. AC minus 5b minus 5c plus AB. All right, I can tell it's not a 3-1 or a 1-3 because, again, there's no perfect square trinomial there. There's no perfect square trinomial there. That's typically what I would check first, the 3-1 or the 1-3. And if neither works, then doing the 2 by 2, the 2-2 factoring. All right, so I'm going to check these two, and I'm going to check these two. What problem do I run into? Does AC and 5B have a GCF? Nope. So then we have to think of regrouping. Now there's usually more than one way to regroup. Like I may do it one way, you may do it another way. Press pause, try it on your own to regroup and see if you can get it. And then press play and see if we did it the same way. We may have the same answer but did it differently. So again, press pause, try it on your own, and then press play. Okay, I'm going to regroup AC minus 5C, so I can take out the C, and then plus AB minus 5B. The only reason why I flip these around is so that can be positive. Now you may have done it negative 5B and then plus AB, that's okay. You would just have to make sure you factor a negative out, which I don't like to do if I don't have to. All right, my GCF here is C, that leaves me with A minus 5, plus my GCF here is B, that leaves me with A minus 5. I can see already they both have a common term, common factor. The common factor is A minus 5, and neither one of them are squared, so I'm not doing A minus 5 squared, just A minus 5. And that leaves me with C plus B. All right, now someone else, I'm just going to put a little thinking bubble here because that's not the only way to regroup. Someone else may have done negative 5B minus 5C plus AC plus AB. They could have done this and did it this way, and in the end still end up with the same answer. So it's totally, I mean, up to you and how you regroup it, but in the end we should end up in the same place. Okay, number 3, x squared minus 2xy minus 16a squared. All right, as I stated earlier, I typically check the 3-1 and the 1-3 first because those are easy to check if there's perfect square trinomials. And I didn't finish writing this one, or I wrote it down incorrectly. There was a mistake. The way I originally had it only had 3 terms. And then I started talking about factor by grouping, which makes no sense. So let me fix it. Plus y squared should go here. So that's x squared minus 2xy plus y squared minus 16a squared. All right, so there are the 4 terms. And again, I typically check these 2 first because I can quickly find perfect square trinomials. All right, cover the first term. I'm going to cover that negative just really quick. I can tell that this is not a perfect square trinomial. That's a perfect squared, but 2xy is not. So cover the last term. I can tell that looks like it could be x squared's a perfect squared, y squared's a perfect squared. I might be able to factor this to get 2xy in the middle. Let's check if that's possible. X times x is x squared. I need it to multiply to positive, so I need the two signs to be the same. The neighbor tells me that they are both negative, y and y. So they came out the same. I need them to be the same, and they are. X times x is x squared. Negative y times negative y is positive y squared. Inside negative xy, outside negative xy, that indeed is negative 2xy. So, if you take a look, it indeed is a 3-1. Again, you don't know that right away. It's not screaming at you, hey, I'm a 3-1. You really have to look and check. Cover the first term, that's not a perfect square trinomial. Cover the last one, that is, factor it, and then you notice, hey, I can write it like this, which is a difference of 2 squares. Okay, now up here, the reason why we didn't do the 1-3 or the 3-1 up here is because when we did that cover and check, or cover and check, neither one of those were perfect square trinomials, so they were simply just a 2-2. Same thing here. Cover and check, that's not a perfect square trinomial. Cover the last term and check, that is not a perfect square trinomial. So again, that leaves us with a 2-2. This is the first one on today's lesson that we've ended up with a 3-1 or a 1-3. All right, we're not done factoring. I use my big exaggerated parentheses and then my smaller ones inside, plus minus or minus plus. What's going to go in here? X minus y, because when I multiply those two together, I get quantity squared. Plus minus square root of 16a squared is, sorry, 4a and 4a, because 4a times 4a is 16a squared. Okay, now remember, we don't leave nested parentheses, parentheses within parentheses, or parentheses within brackets. So I distribute and then drop on the inside. There's nothing to distribute here, so I'm going to drop the inside. That leaves me with x minus y plus 4a. There's nothing to distribute here, so I'm going to drop anything on the inside, or any parentheses on the inside. X minus y minus 4a. And then always look to see if there's any like terms, or if regrouping allows you to factor, neither of which happen in this case, so that there is your final answer. Okay, number 4. X squared minus y squared minus 27y minus z squared. Again, 4 terms, factor by grouping, and as I said earlier, I always check the 3-1 or the 1-3 first. I'm going to cover, and I'm also going to cover the negative just for a little bit, and I hope I did mess up again. I'm so sorry. Can't read my own handwriting. All right, if you will please fix that. X squared minus y squared minus 2xy minus z squared. That's x squared minus y squared minus 2zy minus z squared. All right, so I would cover the first, I cover the negative just for a little bit. Y squared's a perfect squared, z squared's a perfect squared. Could I possibly factor this where it's exactly the same in each parentheses and the middle term is negative 2zy? It looks like I possibly could, but I am running into one problem. I'm just going to bubble this, underline this guy down here. If I'm trying to factor this using a perfect square trinomial, I cannot do that with this leading coefficient being negative. So you're going to have to GCF that first. So that gives you x squared minus parentheses y squared plus 2zy plus z squared. Do you guys see how that happens? A negative times a negative is a negative. This negative and that positive would make that negative. And these, nope, that should be a, nope, that's right. A negative and a positive make that negative. All right, so why did I do this? So now when I cover the negative, now I really truly can factor this as I need to. Couldn't factor it up here because that leading negative there was in the way. So I factored it out, put parentheses around everything else, and now I'm going to do the double bubble. What times what is y squared? That's y and y. What times what is positive z squared? That's z and z. Two signs are the same because it's positive. The neighbor tells me that they are both plus. These two have to come out to be exactly the same in order for it to have been a perfect square trinomial, and they did. Y plus z, y plus z, zy, zy, 2zy, so it did work. So this indeed is factorable. I'm going to write the second piece as quantity squared. All right, so I'm going to come back up here and make a note that this is a 1-3. First term by itself, and then 3 at the end. Where this one over here is a 3-1 because I used the first 3 terms to factor, and the last term just stayed as is. 3-1. Versus a 1-3. Again, don't forget, make notes to yourself, questions to ask me tomorrow in class. All right, I'm hoping everyone at this point can see, oh, this is difference of 2 squares. Difference of 2 squares. And since I have this chunky quantity squared here, this is the one where I'm going to use my big parentheses. X plus parentheses, X minus parentheses. And the reason I'm using x into x is because x times x is x squared. And I always factor difference of 2 squares using a plus and a minus, or a minus and a plus. And inside is y plus z and y plus z, because when I multiply those two together, I get the quantity squared. And as I've been doing on a ton of these problems, you look inside if there's anything to distribute. And if there's not, you drop the parentheses. If there is, you distribute and then drop the parentheses. There's nothing to distribute in there, so I'm just going to drop the inner parentheses. There is something to distribute here. There is a negative. So x minus y minus z. Combine like terms. There's no like terms to combine. See if you can rearrange and factor. No rearranging is going to allow me to factor. So this here is the final answer. Okay, number 5. 8x cubed plus 27. Wait a minute, there's no more 4 terms, so this is definitely not a factor by grouping. There's only 2 terms. It's not a factor by grouping. Numbers 1, 2, 3, 4 were all factor by grouping. This is the first one in today's lesson that is not. 2 terms, GCF? No, there's no GCF. Difference of 2 squares? Definitely not. That's not a minus sign, and these are not perfect squares. That leaves us with cube factoring. And I'm hoping everyone remembers cube factoring. All right, cube factoring looks like this. If you have something that's a cubed plus b cubed, this is the SOAP, if you remember the SOAP factoring, same, opposite, always positive. You end up with a plus b, a squared minus ab plus b squared. All right, that is, there's your cube factoring. You do need to know it. All right, the only thing that changes, if that was a minus, then these signs here would change. And how would they change? With this being plus, this is the same, this is the opposite, and the last one is always positive. That's where your SOAP comes in. Same, opposite, always positive. Same as what you start with, opposite of what you start with, and the last one's always positive. So if this had been a minus, it would be minus plus plus. All right, so what I suggest, the first thing you always do is break down to find out what your A and your B are. Otherwise, you're going to mess up the problem. So what to the third is 8x cubed. In parentheses, what times what times what is 8x cubed? That's 2x. That means your A is 2x. What to the third is 27? 3. Because 3 to the third is 27. All right, so let's put our parentheses. And it's simply A plus B. A being the 2x, B being the 3, plus, because we started off with the plus. Next set. We're here. A squared, be careful. Kids often do this. Don't write it down if you're working in pen because I will erase. They'll say, oh, that's 2x squared. So I'm going to square. 2x squared is 2x squared. That's not true. You're squaring all of A. So think of it as 2x squared, which is 2x times 2x. So that is 4x squared. Okay, same. So that's plus. And then we're here, A times B is 2x times 3, which is 6x, always positive. All right, same opposite, always positive is going to be the 9. 2x plus 3, 4x squared minus 6x plus 9. Same sign, opposite, always positive. AB, A squared, A times B, and then B squared. And that there is your final answer. So the reason you want to make sure you find your A and your B first is that kids often will use the 8 and the 27 in here. Can you take a look and do you see 8 or x cubed or 27 anywhere in your final answer? You don't. The 8, the x cubed, or the 27 is nowhere in your final answer. So you want to make sure you break it down first and not use your original set of numbers in your final answer. All right, number 6. 125, a to the 6th minus b to the 3rd. Okay, so what we are going to do is take a look, and again, there's only 2 terms, which means it's not the factor by grouping or trinomial guess and check. Difference of 2 squares, there is a minus, but that's not a perfect squared, nor is 125, so it's not difference of 2 squares. Perfect cubed, perfect cubed, perfect cubed. And with perfect cube, with cube factoring, it doesn't matter if it's minus or plus. You can work with either one. So this is a cube factoring problem, a SOAP problem. All right, so remember what I said earlier about finding your A and B first. I know they use A and B in here, but finding your first part and your second part, minus. What times what is 125? 5. Now, a little tricky here. A to what power to the 3rd equals a to the 6th? I'll repeat that. Remember, when you do these two, you multiply powers to it. When it's raised a power to a power, you multiply. So what number goes in here? So when you raise it to the 3rd and you multiply those, you get 6. I'm hoping you figured out it is 2. Because a squared cubed is a to the 6th. What to the 3rd is b cubed? That would be b. So this is your first piece and this is your second. All right, So for the a, we're putting not 5a, but 5a squared. Same sign. B is b. And then a squared, you're going to square not just the a squared, but you're also going to square the 5. So think of it like this: 5a squared squared, or 5a squared times 5a squared. That's 25a to the 4th. A squared times a squared, you add the exponents. Same opposite as plus. Same opposite. A times b is just 5a squared b. Always positive, plus, and then we're on the b squared piece. So b is b, b times b is b squared. A, b, a squared, ab, b squared. Same, opposite, always positive. SOAP. All right, make sure you make notes to yourself what to ask me tomorrow in class.